Hey everyone, welcome to problem number 23, merge k sorted list. Okay, so it's a hard difficulty one. So you are given array of k linked lists. Each linked list is in the sorted ascending order. Merge all linked lists in one sorted linked list and return it. So it's a list of linked lists. Okay, it's a tongue twister. Anyway, so you have 1, 4, 5, 1, 3, 4, 2, and 6. All of them are in the sorted order, and you have to return one giant list in a sorted order as well. Okay, so if there is no list, then basically we'll return none. An empty list, same goes for this one. Okay, so what are the constraints? So list dot length is equal to k. So okay, and the list dot length could go from 0 to 10 raised to 4. Each individual list could go up to 500 from 0, and all the numbers inside the nested linked list could go from minus 10 raised to 4 to plus 10 raised to 4. Lists of I is in the sorted ascending order as mentioned it earlier, and the sum of the list dot I dot length will not exceed 10 raised to 4. So basically it's the same thing. Okay, so how do we go about doing it? Well, there are a couple of things in here, right? So first of all of them are in the ascending order. So what you can do is keep a pointer for all the list. So there would be like 3 pointers here, and they will we have to find out minimum of these 3, right? So these 3 pointers, so 1, and 2. So it would give you a pointer, and then whichever is the minimum one we plucked out, we have to do the the next of inside that particular list, right? So basically you have 1, 4, 5 and 1, 3, 4 and 2 and 6. So the first would be let's say C1, C2. These are the pointers or the heads inside the list. So what you have to find out the minimum of C1, C2 and C3, and we should also, while we find out, we need the index to find out which nested list has at what index the nested list has the minimum out of all 3. Once we are done, so then we have to just so say first one, so 1, 3 and 6, so this one is plain plucked out. So now the C1 would point to 4, C2 would still point to 1, and C3 will point to 2. And then out of 4, 1 and 2, now next time the C2 would be taken, and then the C2 would be incremented. So C1 now would be at 4, C2 would be at 3, and C3 would be still at 2, and then again, and so on and so forth till we run out of the list, and so on. So to check, I mean, there are a couple of there are various data structures that we can use. I'm gonna get a heap because it's easier to maintain a heap, and heap could go from a mean heap could give you the minimum of all 3 as well as their index, as you can do. So let me comment this, and how am I gonna build it? So my heap would be empty, and from heap import from heap q, so heap q dot heapify my heap. So whatever I'm gonna push now inside the heap, it's gonna have the minimum value itself. So let me actually start building it. So for index comma head in enumerate lists, right? So what I'm gonna do now is I'm gonna start appending in the head dot vals, right? So the way to do it is heap q dot heap push, and the name of the heap, and the first one goes head dot val, the second one goes index, and I'm just gonna keep the head as well so that it would be easier for me. Now it says that the length, each individual length could go from 0, right? So it would be better to just have this check. So if there actually exists a head for the interlinked list, as I was saying. So anyway, once this is done, so what you can do is we'll start building the result linked list. Okay, so result, so yeah, we could just do result equal to current equal to list node, just the dummy one, right? And what we can do, so while there is a heap, right? So we have to iterate through all the heaps, so till this one. And what you can do is get the main heap val, oops, main heap index and min of heap from heap q dot heap pop. So every time you do pop, it would give you the minimum out of the heap. Okay, and what you can do, current dot next would actually go to min heap, and current equals current dot next. So basically I'm just building up from there. Okay, and what you can do is so this is what you've added in the result, and then what you can do is just do min heap dot min next. So whichever of these, so c1 is done. Now I'll just do c1 dot next basically in here. Okay, and if there is a min of heap, then what's gonna happen, so basically once this been plucked out, then again we want to put 4 inside the heap, right? So that's what I was trying to do. So what you can do, just heap heap q dot heap push, and then my heap, and it would be min heap dot val, index would be the same, sorry, it would be min heap index, and that would be min underscore heap, right? And at the end you would return result dot next, because it's now pointing to dummy, and then we would start printing the result. Yeah, I know it's a little bit tricky. Let's see if it actually works. Okay, heap q dot heap pop. Okay, oh my bad, my heap. Okay, right, and then we'll submit this one. Perfect, it goes through. All right, thank you so very much for tuning in, and see you guys in the next videos. Cheers.